In this screencast, we're going to look at the bonding in the heteronuclear diatomic molecule hydrogen fluoride by building a molecular orbital energy level diagram. Start by adding the atomic orbitals, which are the 1s orbital of hydrogen and the 2s and 2p orbitals of fluorine. Unlike a homonuclear diatomic, you're using different orbitals on the two contributing atoms, so you need to know their relative energies. To decide this, think about the electronegativities of the two atoms. Fluorine is more electronegative than hydrogen, so holds on to its electrons more tightly. This means that the fluorine 2p orbital is lower in energy than the hydrogen 1s orbital. The energy gap between the hydrogen 1s orbital and the fluorine 2s orbital is very large, and as a result, there's essentially no interaction between them, despite them having the correct symmetry to interact. This means that the 2 sigma orbital is essentially a non-bonding orbital with the same energy as the 2s atomic orbital. The hydrogen 1s orbital and the fluorine 2pz orbitals also have the correct symmetry to interact, and these are closer together in energy. They therefore interact together to form a sigma bonding orbital and a sigma anti-bonding orbital. Note that the orbital label does not have a G or a U part, as the molecular orbitals don't have centers of symmetry. The final atomic orbitals to consider are the fluorine 2px and 2py orbitals. These don't have the right symmetry to interact with the hydrogen 1s orbital, so become non-bonding orbitals. Now you've got all of the molecular orbitals, you can put in the electrons. 8 electrons go into the orbitals, so the 2 sigma, 3 sigma, and 1 pi orbitals are occupied. Since non-bonding orbitals don't contribute to bond order, there's one filled bonding orbital, the 3 sigma, and no filled antibonding orbitals. This means that HF has a bond order of 1.